Hey guys, good afternoon. Please confirm you can hear me.
Yes, I can.
All right. Happy to be in this session. Elizabeth, thank you for the introduction. I'll just share my screen with everyone, then we can get started. Please let me know if you can see my screen.
Yes, I can.
All right. Yeah, so this session we're talking about the data analysis ecosystem, demystifying this ecosystem, and we'll basically be talking about how you move from data jungle to actionable intelligence or actionable insights, whichever one you prefer to use. I think we already did the introduction part. My name is Chukwubuikem Ngwoke. You can call me Chu Ngwoke for short. Um, I am available on LinkedIn, Chukwubuikem Ngwoke, same on other social media as well, so we can connect after this. So let's just jump straight into it. For this session, we'll be talking about quite a couple of things. We'll start with an introduction to the data analysis ecosystem. We'll look at just generally different steps in this ecosystem. First being data sources, data collection. We'll talk about data storage and data management generally. We'll look at data processing and also data cleaning. We'll talk about data analysis itself and things involved in data analysis. Look at data visualization and data presentation. We'll also look at the tools in data analysis ecosystem. We'll round off roles in the data world and a couple of challenges generally that data professionals face. Then we'll have opportunity for a Q&A session. I'll be available to answer all your questions. Yeah, so to get started about introduction to this ecosystem we are talking about. So generally, what's the data analysis ecosystem? How does it fit into the whole? Because the broad idea of the ecosystem, the broad idea of data in general is you're trying to make data driven decisions. So how does this ecosystem drive data driven decisions? So essentially, this is the data analysis ecosystem. There are a set of processes, or we say tools and techniques that organizations and individuals themselves use to collect, store, process, and analyze data to extract valuable insights, essentially trying to optimize business processes. So you could see that there's some words which have been underlined here. These are actually the words that make up that ecosystem. So essentially, it starts from data collection and ends with actionable intelligence. So there are different steps involved. You go through the data collection, then the data storage. You pre-process this data processing before you do the analysis itself. So when you are done with analysis, there's a data visualization part, a data presentation part. Before we now talk about extracting the intelligence, extracting insights from it so that we can make actionable decisions from there. This session is supposed to be interactive. I mentioned that to Elizabeth as well. So I don't like to be the only one talking throughout the session 1 hour or so before we get to the Q&A. So if you have such a question, you can drop in chat or you can raise your hand and I'll take your questions as we go. I think it always works better for me. So moving on, what's the significance of all of this that we're saying so far? What's the significance of why do we want to look into this ecosystem? So a ton of data is being generated every single day in the world right now. Approximately 328 million terabytes of data created each day. This is a mind-blowing amount of data. It spans across a whole lot of different sources, social media sources, this data that organizations generate. So there's a buzz about what do we do with this data that we're generating. They can't just sit there. We need to make ourselves and our business processes better with this data. So organizations across industries are increasingly relying on data analysis to make informed decisions, to drive their strategy, to gain a competitive edge with the vast amount of data that they are generating day in, day out. So, real world examples of companies who have used this high profile ones: Amazon, McDonald's, Uber Eats, Netflix, virtually every organization around you in different scales, both small, medium scale business around you. If you look critically, you see that one way or the other, they are trying to use data to better their processes, to maximize profits, to beat the competition. So that's essentially why we are trying to look into this data analysis ecosystem and why it is important that you understand and see how you can key into this ecosystem. So let's just do a little bit of a case study about some organizations who have been able to get something out of data analysis. Let's look at McDonald's, for instance. It's a food industry, and the industry they operate in is very challenging one. It's dynamic, it changes. It's not the stuff that people want today that they want tomorrow. So all of these things are constantly changing. So what's McDonald's trying to do? So they want couple of years ago, they wanted to transition from mass marketing because it used to be trying to market the same thing to a whole lot of people, entirely, essentially, entire country. And then they were trying to move from this mass marketing to mass customization. For them to do such a thing, they needed to look at the data they've collected over the years and how they can make this data useful to their customers. How can we use this data to recommend better products for customers on an individual basis? So what they came essentially after the analysis, they were able to come through with their different recommendations, like what they do now. They drive through where they have per customer recommendations, a variety of products that they recommend to you that can vary based on the weather, based on the day of the week, based on the season, and stuff like that, like recommending a cold beverage for you on a hot day. So this would not have been possible if they had not gone to analyze that data and they've been able to record higher sales and actually still be a leader in their own market over the years. So this is all thanks to data analysis, what we are studying today. So we still look at one more, say Uber Eats. This one, Uber Eats is quite a popular brand. They set out trying to be that delivery giant that is known for kind of always delivering food by its form, always being able to deliver food when you want it and when you need it. So they try to model their business around the cab hailing that they were already doing, basically trying to be able to predict the exact time that they can pick up this food and deliver it to you. So that when you open your app and they tell you that your food arrives in 10 minutes, you know it's 10 minutes. And then customers were really able to key into that and their business processes were optimized and it was better. This would not have been possible if they did not look at the data they collected over the years and then model and work with this data. So essentially, these are all of the things that companies are doing with data analysis. There are a whole lot of different other examples. If you look at the retail business around you, you could see that maybe these people are looking at their sales over some years and trying to see how they can minimize wastage, basically minimize their storage, the overhead from maybe storekeeping and trying to always keep the most in demand goods. So all of these things are things that businesses are doing with data, and that is what we data professionals try to help businesses do. So moving on to that, let's talk about the first step in this ecosystem, which is the data sources and the data collection. Essentially, this is where it all begins. This is the most important of them all because you need to first of all identify the data that you need. So you have a question, you have a problem that you're faced, and you come to the decision that you do not want to make a gut feeling decision. I just want to decide, maybe let's do this. I want to make a decision based on data. So the first step is you need to collect the data you need. You need to identify where this data is. So data sources are essentially the locations or origins from which data is collected and extracted for analysis. So they can encompass a wide range of places, where the data is generated, gathered, or stored. And then some common examples are databases, spreadsheets. I'm sure everyone here is familiar with spreadsheets, cloud storage, external APIs, IoT sensors. These are basically just sensors from smart applications. And then there are tons of data on the web. So these are some of the common data sources that are available and you can use. So this essentially is just a little kind of visualization to show you all the different data sources available there. There are archive data, basically organizations. Let's say a hospital, for instance, there are files upon files upon files of data that they store in their storage room, and this data was archived. And should this hospital ever one day need to look into their historical data and try to make decisions of it, they will need to go to this archive data. Your internal documents that companies generate day in, day out, multimedia files, basically digital photos, pictures, videos that organizations take. There are machine log data. This is basically every smart system, every computer, every phone out there now they keep log data. So your computer knows the last time you logged in. It knows the different times you've logged in over the past 2 years. It knows if your system should ever have a problem, like it should crash. You can always pull the machine log data and try to find out what was the error that caused this crash and some of these things. So on a larger scale, companies who deal with servers always look at the server logs to see if there was an error, who accessed what, and all of those things. So social media data, I think everyone is familiar with this one. A whole lot of information is out there on social media. You have sensor data, traffic sensors, all sorts of sensors collect data regularly, and these are available. So they're public web sources, operational and analytical databases. So I just want us to talk briefly on these two databases and public web sources because I think it's a kind of a bit of the most important ones for, let's say, business and then for individuals. So when you talk about public data sources, you're essentially talking about the concept of open data. So when you hear open data, what does that mean? So open data essentially refers to data that is freely available for anyone to use, to reuse and to distribute without restrictions. So you always have access to this data. Examples are government data. So governments around the world always release data through their agencies, and this data is freely available for anyone to use, to analyze, and to draw inference from it. There's scientific data. A lot of research findings are out there, freely available for anyone to use. Climate data is also available out there. You can always know what the weather is or today and even far back as 5 years ago. So these ones are freely available for everyone. Economic data is also another source of another open data. Economic indicators, financial data, stock market data. If you want to know what the price of a particular stock was far back as 5 years ago, all of these data are freely available for use. Environmental data, you can talk about air quality, water quality, biodiversity data. All of these things are publicly available for use. So I just put in some links to some of the sources that you can go to get this public data, this open data. So data.gov is essentially open data about the US. So if say you want to look at the employment data, crime rate data, all of this stuff about a country. Say for US, you can go to data.gov. For UK, you could go to data.gov.uk. For Nigeria, is also there. The Nigeria Bureau of Statistics, they always release data about a lot of indices for the country. So this is available. Cargo.com is also another interesting one because it's more like a repository for this kind of data for a whole lot of different say countries, use cases. I started it because not every data set of cargo is open data, but they have a lot of open data that you can use. Um, a different one notable is Titanic data. So, for someone who wants to coming in new into data analysis, you want to play around data. There's this interesting data set that Cargo has. It's Titanic data, basically just giving you information on passengers who were on Titanic, the famous Titanic ship that sank. So it gives you basically demographic data about passengers who were on it and people who survived and people who did not survive. So a lot of interesting analysis that you can make off of that data set. So these are kind of the things that you do with them open data. Moving on also in data sources, it's also important that we talk about data quality because data quality is the measure of the condition and reliability of your data. So how reliable is your data? So before you go ahead and make an analysis, you need to understand the quality of your data because data analysis is only as good as the quality of the data it relies on. So if you tell me that you've done this analysis, I want to know, can we trust your data? So because if your data is not trustworthy, I can't trust the analysis you've done. So before you even move on from data sources before you move on to data collection. You need to first of all establish that the data have it's quality data that you're collecting, the quality data you are dealing with. So this is a little flow chart. Let's just call this a chart that kind of shows the key dimensions of quality data. So essentially, you need to think about accuracy of this data. So accuracy is basically saying, does the data you're dealing with, does it accurately represent the reality? Does it have a verifiable source? So you need to answer this question in the affirmative before you move on to collect this data or before you move on to do any analysis of this data. You need to be sure that this data it's not representing A when you are speaking about B. You need to be sure that it has a verifiable source. It's not dubious. It's not misleading. So the second step is the integrity of the data. So does the structure of the data, are relationships maintained? Is there a protection of the data from tampering? Because let's say you've gone to, instead of going to, let's say, Nigerian Police Statistics, instead of going to your website to download the data, you're going to a blog to download the data about crime rates in Nigeria. So you run the risk of that data haven't been tampered from when was moved from the website of real statistics to that blog. So there's that risk of tampering. So it's easy, it's better for your analysis that you download it from the original source than from the blog you're downloading. So these are the considerations you need to take into account. Third one is consistency. Is there a consistent definition for data elements? Is the interpretation of data consistent? In that sorry, that let's say you have a column in your data that measures the weight of people. So you need to be sure that every weight recorded on that column is in kilograms or is in 1 unit. So you don't have 10 rows in your data measuring weight in kilogram, another 10 measuring rows weight in pounds. So if the data is not consistent, you cannot make analysis with it until you fix these data quality issues. The next step being completeness. Is all the necessary data present? How comprehensive is the coverage of information? So completeness is a bit tricky and a bit arbitrary to answer, but it's important that you consider it in terms of population and sample. So let's say you are dealing with an analysis. I also use a crime rate in Nigeria, and then the data you've collected only shows the crime rate in 2 states in Nigeria. Or let's say you are dealing with a crime rate in Europe, and the data you've collected only deals with the only shows crime rates in 4 countries in Europe. This data is not complete because it's not an accurate presentation of the population, which is all the states in Nigeria or all the countries in Europe. So these are the considerations that you put into place, and there are a whole lot of different guidelines out there that you can always consider on your own or check the internet for stuff that can help you determine population size and sample size and all of these things. So, but you need to be able to answer this question on completeness before you can use your data. Another one is the validity of the data. The data you're dealing with is it valid? Does it have a defined format, type, range, all of these ones? Then finally, timeliness. Is the data available when you need it? Is it maintained? Is it managed? Still running with my example for crime rates. If I want kind of look at the crime rates of a particular country and the data I have only gives me historical crime rates like up until 2005. This data is not timely. It's not that relevant to me. So you need to be able to answer all of these 6 questions in affirmative before you can consider your data, quality data that is suitable for your analysis. Again, please let me know if you have questions. So moving on, we've identified our quality data. It answers all our 6 dimensions. Next step is the data collection. So I'm kind of just a high level of some of the methods, the tools, and the techniques that you use for your data collection. So in terms of methods, it could be you're extracting data from a database, it could be interviews, survey, it could be web scraping, digitization of OCR, which essentially maybe you have a whole lot of physical documents and you're trying to scan these documents and then read them into maybe a spreadsheet or database as OCR experiments as well. Let's say you you're a research student and you've done a lot of experiments and maybe you're collecting temperature readings, soil sample reading, all of those things. So those are methods that you can use for data collection. And in terms of tools, there are spreadsheets, GIS tools, video devices, sensors, a whole lot of different tools out there that you can use for data collection. The last leg of it will be the techniques that you use. This is just a high level because SQL, we use SQL to get data from your databases. You could use algorithms like programming languages, Python, R, and all of those. If you are dealing with let's say web scraping and other different forms. But essentially, this just shows you the steps involved in data collection. So whichever step you use depends on your own particular use case. So in terms of key takeaways for this step, data sources are the starting point for the data analysis. And then they come in various forms and locations. So the last key takeaway for us in this part is that the quality of the data source directly affects the quality of your data analysis. So this is the key takeaways that you can get from data collection. So the next step in our ecosystem is data storage and data management. So what is data storage? We've collected the data we need. We determine that it's quality data. So we need to store this data somewhere for when we are ready to use it. So data storage is the process of holding, preserving, and organizing data in some structured manner. Structured here might be a bit contentious because it could be structured, it could be unstructured. But the important thing here is that if you are preserving, you're holding, and you're organizing this data for some future use in however manner that you choose. So data storage can include various types such as databases, you could use data warehouses, cloud storage, a whole lot of other different forms. So what I've identified here are basically enterprise grade examples, database, data warehouse, cloud storage. For small scale businesses or individuals, you could essentially just be storing your data on a hard drive on your local machine or some other file storage or some other network device, or essentially you're storing this data in a particular format which has been predetermined and which has some governance approach to it. So why is it important for you to store data? It provides a secure and reliable repository for your data. So you know that it's always there. You're not going to lose this data. And then you have some disaster recovery for scenarios where you should lose this data. The second one is that it allows for historical data retrieval. Let's say your data source is coming from some sensor that you are reading, maybe temperature readings, soil sample readings. If you're storing this data, then after like 4 years, you can now always go back and get the very first soil sample reading that you had because you're storing this data. So it supports data integration and accessibility for analysis. So we look at data integration at a later slide. But essentially, if you're storing your data, you can always integrate it to the different things, however you like it. And this will be accessible for any analysis that you want to do further down the line. So next step, I'll look at the types of data storage that are available. Their databases, enterprise scale, their data warehouses, their data lakes. So these are kind of the three distinct ways that enterprises can store their data. And there's also a cloud storage. So one important thing I want us to look at here is the concept of on-prem cloud storage or hybrid storage. So what is on-prem storage or on-premises storage? So on-premises storage is when an organization stores their data on site. So let's say you have an organization that work in the financial sector, work in the bank. Your, your data, the data we generate, let's say it sits somewhere inside that bank. That's the concept of on-premise data. So even if it's a server, that server sits somewhere inside that organization, and physically you see that this is what holds our data. So this is contrary to what cloud storage is. So cloud storage is essentially that somewhere in the cloud storage you store this data. So there are a lot of cloud providers out there. Let's say Google, Amazon, um, Microsoft Cloud, all of these things. So we could have a cloud storage that all the data you generated, it's nowhere physical in your office. It's nowhere physical in your organization. Just sits in some cloud storage. Another one is the hybrid storage. This is more like the most common option for a lot of organizations where your data sits both on-prem and on the cloud. So maybe you have some of your data that are on cloud and some that are on-prem. So these are just kind of this distinctions that you have in cloud storage. So I want us to look at databases. What are databases? So databases are more like extensive repositories for structured data and information, and databases are primarily for OLTP. So let me just describe what OLTP scenarios are. So OLTP, online transaction processing, it means that your database or your application, you essentially optimize it for transaction processing. I'll give a case, an example of my own line of work. If you want to use a banking application, let's say your mobile app, you are generating data, you are transacting. So the database is optimized for to record that transaction you are doing, not generally to retrieve it. So that one is more like a transaction process. That's what you call OLTP. So all these databases are optimized for you to for the applications to do transactions. So this database is prioritizes efficient data accessibility and retrieval processes. It excels well at transaction operations, but databases are not really suitable for intensive data analysis. So the database that is being used by that mobile app you want to use now to record the transactions you are doing, it's not essentially the same database that maybe you as a data analyst is going to use to maybe show a visualization or to report on all the transactions that has happened in a day or has happened there in a year. So these are kind of the concept of OLTP. There are a whole lot of different kinds of databases out there, but essentially that you can group them into two: SQL databases and no SQL databases, or relational and non-relational databases. So relational databases, essentially they use SQL to retrieve data, and they store data in some kind of relational form in rows and in columns. So notable examples: MySQL, Oracle, SQL Server, Postgres, all of these are relational databases. They have a rigid schema and they support a relational database management systems. You could write a whole lot of complex queries, join, maybe you can have 5, 10 tables that you are joining to generate whatever data that you join. So these are majorly the most common type of databases that you will find out there. There are also NoSQL databases. These are kind of the more like advanced kind of databases that they support way larger amount of data than NoSQL databases. They don't have, contrary to SQL databases, they don't use a rigid schema. They have flexible schema. They support distributed data management. So instead of RDBMS, they have their distributed data management softwares. They optimize for simpler queries against the complex queries for SQL databases. And another key example difference between two of them is that SQL databases they are vertically scalable. So if you have an Oracle database and your organization is growing and you want to increase your database, what you need to do is you need to add more memory to this. So if your database initially was maybe 60 terabytes, you can scale it up to 100 terabytes. So this is vertical scalability. But most SQL databases don't scale that way. They scale by adding nodes to the system. So if you have a Cassandra database and tomorrow your organization increases, you can't just stack more terabytes on top of it. So you add nodes. So essentially, a Cassandra database, you can picture it like a 20 computers, and each of these computers or each of these servers are holding your data. So tomorrow, if you want to add more storage, you don't just go add more storage on one of those computers. You essentially add more servers, more nodes to the database itself. So that's kind of key differences between these two types of databases. Let's also look at the concept of data warehouse in data storage. What is a data warehouse? Data warehouse is like an advanced system designed to effectively store highly organized data or information gathered from multiple different sources. So it serves as a repository for both current and historical data for various systems. So let's say in an organization there can be 10 different databases. For each application might have its own database. So the data warehouse is essentially a storage for all of the information those databases hold. So this database might be optimized for this application, another database for another application, all doing different things. But in a way, all of these data come together and live in the data warehouse for easy accessibility. So that's essentially what a data warehouse is. The primary objective of employing a data warehouse is to integrate diverse data sources, enabling in-depth analysis and discovering valuable insights, essentially for you to create your business intelligence reports. So, like I said earlier, this is the concept of OLAP, online analytical processing, which is in contrast to OLTP. So, databases are optimized for transactions. Each application has its own database that handles the transactions on that application. But a data warehouse is essentially for analytics. So all of these databases are doing their own transactions, and essentially eventually the data they hold comes into the data warehouse. They are aggregated together, and then data analysts, data scientists, essentially the data professionals can now get this data from data warehouse for their own use. So that's the concept of OLAP, analytical processing. So the next one we look at is the data lake. So what is a data lake? Data lake is essentially like a data warehouse, except that it stores data in various sources in their original and unmodified formats. So whereas a data warehouse will store data after transforming it, the data lake does not transform the data. It just stores it the way it comes from. It comes from the original source. So it accommodates structured, semi-structured, and unstructured data, enabling storage of raw data without any processing or transformation. So the transformation is done when you need the data during retrieval. Data lakes, again, are also for OLAP because they are very similar to data warehouses, but they offer cost-effective alternative to a data warehouse. So this table just shows you like differences between all of this, the database, the data warehouse, and the data lake. So for workloads, the database is majorly for transactions, for operations, the operation side of the business. But the data warehouse and data lake are for analytics. For structure, the database stores structured and semi-structured, same with the data warehouse, but the data lake highly unstructured. For the freshness, the data refresh, your database is real time. As long as you're interacting with an application, you're writing data to a database. But data warehouse is based on ETL frequency. So let me just at this point explain the concept of ETL and ELT. So ETL, you're basically extracting data from a database, then you're transforming this data and you're loading it somewhere. So that's how data comes into a warehouse. Data is extracted from 10 different sources, 20 different sources. Some transformations are done on this data, and then they are loaded into your data warehouse for people in the downstream to use. Well, this is in contrast to the data lake. Data is extracted from maybe that same 10 data sources, but it's loaded directly to the data lake without any transformation. The transformation comes later whenever whoever wants to use the data now transform the data as the last step. So this is an ETL. You could schedule an ETL. Say for us in the financial sector, your ETL could be at the end of every day. So every transaction that happens maybe across the across the organization at the end of the day will now you now do the extract, the transformation, and the load it into the data warehouse against the next day. So it could be daily, it could be monthly, it could be weekly, it could be maybe 2 hours. So that is the refresh frequency we are talking about here. So for intended users, database is basically for the developers. Developers that build applications are the ones that interact majorly with the database. But for the data analysts, data scientists, they interact majorly with the data warehouse, the data lakes. Again, please let me know if you have questions at any point. So let's look at data management. What is data management? Data management is basically the process of organizing, storing, and ensuring ensuring data quality and security. So, store data, we need to manage this data. And data management includes data governance, there's data integration, data security, there's quality assurance. So, all of these things are basically just dimensions involved in data management. So, the next step after you've collected your data, you stored your data, you're managing your data. Next step we should talk about now is you're preparing for your analysis. Before your analysis, you need to process this data, you need to clean this data. So what do we mean by data processing? It's the process of cleaning, transforming, and organizing raw data into a usable format for your analysis. So emphasis here is a usable format because oftentimes data comes in the format that is it's not really that useful. It's That's a lot of issues that in this data. So you need to be able to do elaborate cleaning of this data to support the analysis that you need. Uh, there are various tasks in data cleaning. There's data transformation. You need to handle missing values. You need to handle duplicates in the data. You need to handle outliers. A lot of different forms in data processing and cleaning. So it's also important to note that as data analyst, you're going to be spending a whole lot of your time cleaning data because your data analysis is only as effective as the data cleaning that you've done. So data cleaning again is the process of identifying and correcting errors and inconsistencies in the data. Very important step in the ecosystem. So common tasks being removing duplicates, concatenating columns, removing outliers, concatenating columns, essentially just joining two columns. So let's say a very common one that happens is a lot of this applications. Let's say you're filling out the form online, most times when they ask for address, you see address line one, address line two, state, street, and all of those things. So when eventually you want to use this data, you have to join up these columns to have an address column. Again, a lot of these applications you see they need to fill first name and last name in different lines. So on your database, you need to join this together to actually have a name for each customer or whatever it is. So that's what we mean by concatenating columns. So data professionals generally spend a significant amount of your time on data cleaning. So let's just talk about some of the common data cleaning techniques. One of the most important one is handling missing data. What is missing data? How do you handle it? So missing data is essentially you have a rule. So you've collected data on 1,000 students, for instance, and then out of 1,000 students, yeah, say for the age column now, you have just 800 people that have supplied their age. So you have 200 missing data, missing age data. So that's what we mean by missing data. Essentially, two different ways you can handle missing data. Either you delete the rows that are missing, or you impute the data for the ones that are missing. So for deletion, let's say same example, you have 1,000 data points for students, and then 200 did not supply their age. For deletion, you delete the entire 200, and you'll be left with 800 students to work with. For imputation, you try to impute, essentially guess the age of these 200 students. So it's important to note at this point that there is no good way to deal with missing data. Missing data is a problem, and all you can do is to try and have your own solution to it. There is no best way and there is no good way to deal with it. All you can do is depends on your data sets, and then you try to just find a compromise for dealing with this missing data. So I want to recall this famous quote by David Rubin. A lot of times when you bring up deletion and the imputation, people will always tend to choose imputation. But the idea of imputation, yeah, it's seductive, but it can be dangerous. Because for example, now we are running with 1,000 students. If I should do a poll here, a lot of us are going to choose that they want to increase the age of these students, so that if you want to stick with your sample size of 1,000. It can be good, but it can be dangerous, and a lot of considerations need to be put into before choosing imputation. So just done a little bit of a flow chart here to help to guide you for how to handle missing value. Whether you choose to do deletion and imputation, it needs to be a guided decision. So for deletion, you want to think about why do you want to choose deletion? Why do you want to choose imputation? So, should you want to choose deletion, how also do you want to delete? Are you deleting rows? Are you doing pairwise deletion? Are you deleting columns? If you are doing imputation, do you want to consider if it's a time series? Say if it's a time series now, time series data without trend and without seasonality. So you want to impute it with mean, median. First of all, when we talk about imputation, guessing the age, Yeah, generally you don't just you try to do intelligent guesses. So let's say for the same age that we're talking about now, the 200 that do not have an age, you can decide to use the median age as their age, or you can use the mean age. If you are dealing with students, let's say it's university students, and the average age is let's say 21 years, you can decide to give 21 years to all of these students that did not apply their age, or you can decide to use the mode, the most occurring age as their age. So all of these things are just kind of the ways you try to do an intelligent guess of the age. So if you're dealing with a data without trend and without seasonality, the mean, the median, the mode, all of these things can help you. But if it's a data with trend and without seasonality, so a trend is basically that there is a way this thing is going. So a trend might be that 40 students tend to be this age, final year students tend to be this age, third year students tend to be this age. So you need to consider that, so that if the person, the student with the missing ages in fourth year, he tried to use maybe the median of the or the average of the fourth year students, the third year is the average of the third year students, just have to make a more intelligent guess. If it's a data with trend and with seasonality, you need to also do some interpolation. Same if you are dealing with general data, categorical, you can make any level. Let's say categorical data can be male and female, can be categorical, gender. And then there are some people that did not indicate their gender. So instead of guessing whether they are male or female, you could just have another level of unidentified or non-binary, or however you want to call it, instead of trying to guess whether they are male or female. That can be one way to impute data for that one. If it's a continuous data, say you've measured the temperature of a particular place for a period of time, there might be some days that you did not measure temperature. So for that one, you could use, again, you could use the mean, the mode, the median, all of those things. Or you could use some linear regression methods to try to get the 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 value you can impute to it. Again, talking about deletion, um, some of the considerations that will make you not want to choose deletion is you talk about your sample size. So for the example you are dealing with for students, say you have 1,000 students and 600 did not specify their age. So this becomes an issue. If you delete 600 data points, it leaves you with 400. You deleted a very high percentage of your data. So that's some of the considerations, that's some of the lines you think about before choosing whether to do deletion or to do imputation. If it's just 50 students that did not supply their age, this is there 50 out of 1,000 is not a significant figure, so you can just decide to delete the 50 data points. So that's just kind of thought process that go into handling missing data. Again, the next one will be handling outliers. So what are outliers? Um, Outliers generally, outliers are just data points that are far from the truth, far from the domain of your data. So again, with our age example, a student supplies their age as 55 years, and the average age is 21 years. This is an outlier. It's most likely a wrong value. So generally, outliers in data, you clean them by removing them, because if you don't remove them, they will distort your data to a very large extent. So there's a general consensus in data community that outliers, you just remove them. But the major task is, how do you identify what an outlier is? So there's a general rule for identifying what outlier is. And outlier is basically any value that is above Q1 is the first quartile. I want to believe that everyone here knows how to identify your first quartile, second quartile, up until the fourth quartile. So quartiles are basically just the first quartile are values that are falling within its first 25% of your data. The second quartile values are for 50% of your data and stuff like that. So this formula will help you identify outliers. There's also a second one. So the second one is basically telling you that any value that is above 2 standard deviations from the mean or below 2 standard deviations from the mean is an outlier. So most likely, if your mean age is 21, someone that is 55 years is an outlier, and you're better off removing that age from your data set. So I think let's also look at data cleaning tools. What are kind of tools that we use for data cleaning? The first one is use your spreadsheets, your Excel, your Google Sheets, the functions. Some of these applications that have a lot of functions that can help you with data cleaning. Something like concat, stream, VLOOKUP, a lot of things that you can use for your data cleaning. You can also use Power Query functions for people with some experience with advanced Excel. You know that you can do a lot of things with Power Query. Um, Python libraries for people with programming languages, NumPy, Pandas. These are libraries that can really help you with data cleaning. Also, people that can write in R, tidyverse, tidyr. These are really, really helpful packages that you can use to clean data. So that's all about data cleaning. Some of the challenges that you face with data cleaning. The major one is data complexity. Sometimes the data comes in very complex form that it's not so easy for you to decide how you want to clean it. Say, for instance, address is a very common complex data that it's not so easy to clean. There's a lot of different things that your address can come, and it's not always so feasible to clean this data. So this is one of the challenges in data cleaning. Next one is time constraints. Data cleaning can be a laborious process, it can take a long time, and depending on analysis you are trying to do and the time factor, you might not have so much time to be able to do the same analysis. The last one is the need for domain knowledge. So for you to do data cleaning, you need to understand the domain in which the data exists. An example that we have been dealing with about the students, for you to be able to know that a 55-year-old person is an outlier in the university environment, you need to actually understand what the university environment is. This is a very simple example, but it translates to every other area in the financial sector. For you to know what an outlier is, you need to actually understand what the data is talking about. You need to understand what the business is. So that's it about data analysis. So to summarize so far, we've talked about data collection, we've talked about data storage and data management, then we've talked about data pre-processing. So the next step now is the analysis. So we've collected data, stored data, process the data. Let's now do our core analysis. So analysis is the process of examining, transforming, and interpreting data to uncover patterns, trends, and discover valuable insights from this data. Emphasis on valuable insights. Um, Data analysis can vary from simple to very sophisticated methods and tools, but the fundamental goal is essentially to generate insights and to drive data-driven decisions. We are trying not to make gut decisions. We are trying not to make decisions with how we feel, with emotions. We are trying to make decisions off data. This is essentially why we do data analysis. Generally, the first step in any data analysis is EDA, or we call exploratory data analysis. You try to explore your data. You do not come with any bias. You just try to look at data the way it is and then try to see what you can find in it. So let's look at the types of data analysis. Essentially, there are four types of data analysis we will look at. The first one is descriptive analysis. The next one is diagnostic analysis. Also look at predictive analysis, and the last one being prescriptive analysis. For want of time, I'll try to hurry up a bit. This kind of just shows an overview of all these four types of analytics. Essentially, you start from your data, and then you're trying to reach a decision, and then take an action. So how does these data analysis steps or types, how do they help you? So when you're talking about descriptive analytics, you're asking yourself what happened. And then you can see that this is the most away from an action, a decision, because a whole lot of human input, after you identify what happened, a whole lot of human input is going to be needed for you to take a decision and take an action. Let's use an example. You have a data about a population, and then maybe crime rates and out of school children. So let's say you're trying to ask yourself what happened. You identify that the out of school children, there are a lot of out of school children in a particular place, a particular state. So this is what happened. You've identified what happened. So essentially, you are trying to take an action, but identifying what happened alone cannot help you take an action. A whole lot of things you might not have to use your emotion to say, okay, in this state, there are a lot of out of school children. Let's do this, let's make this decision and take an action. But instead of using that human input, you can go a step further in analysis and ask yourself, why did it happen? So when you're asking why did it happen, you're dealing with diagnostic analysis. So if you identify why it happened, you've cut down some of the human input that you need to arrive at your decision and take an action. So if you identify that a particular state in a country has a lot of out of school children, you're asking yourself why. And digging into the data. Um, is it because of income? So essentially, when you are dealing with diagnostic analysis, you begin to combine variables. So you might be looking at out of school children, maybe count of out of school children and income of parents, or count of out of school children and the size of family. And you begin to combine these variables, trying to see the relationships. Is it does income have something? Maybe this state has generally low income parents. Maybe this state generally has uh, a bad road. So a lot of other things that you can take into consideration that will help you understand, identify why this thing that happened has happened. So to further cut down the amount of human input you need before you arrive at an action, you can ask what will happen. You are predicting what will happen. So let's say essentially we are looking at crime rates and out of school children. So we've seen that this particular area, this is a trend for out of school children that has been growing over the years, and crime rates have also been growing over the years. So we can use that and do predictive analysis and try to see what are the things that influence crime rates. Is it only out of school children? Are there other things that influence crime rates? By the time we identify all of these things, we can try to predict what will be the crime rate in the next 5 years. So this kind of predictions will help us further with the decision we need to take. So we've identified that crime rates probably reach a catastrophic level in the next 10 years. That will spur us further, steer us further to try and take a decision at this moment and also an action. So prescriptive analysis is essentially the last step of it, where you try to take into consideration all that you've done, and then you decided that okay, income is a problem in this place, that it leads to more out of school children, and then also crime rate is going up. What do we do about income? Do we establish more industries? Do we raise the minimum wage? Do we just basically try to prescribe a solution? So essentially, these are the steps that data professionals, these are, you go through all these four different analysis, and this is how you come back to a data-driven decision. So after your prescriptive analysis, you can now go to your stakeholders, whoever is in charge that will implement this decision, and you show the data, you show the analysis you've done, and then you help them, you convince them to take this action. So that's essentially the data analysis in a nutshell. So after you've done this analysis, before we move to data visualization, there are a whole lot of different tools you can use this data analysis. There are programming languages you can use. You mentioned Python, you mentioned R. There are ones that you don't need to write so much code, SPSS, a lot of different tools that you can use out there. Even Excel, you can do a data analysis in Excel. So it only depends on what the organization you're working uses and what your expertise is. But I also want us to touch about data visualization at this point. So a lot of times, data analysis you do are quite elaborate. A lot of different, let's say, imagine you're building a model or you're doing analysis that you write lines and lines and lines of code. How do your stakeholders don't have, imagine you're presenting to the executive director of your company, they don't have this time to look at all of the codes you've written and to look at everything you've done. So you need to be able to visualize your outcomes, the results of your analysis in a nutshell way, in a very compelling way, so that they see at a glance, then they've seen what you're showing them and they're able to take those decisions you want them to take. That's what we are looking at in data visualization. Generally, the graphical representation of data to facilitate understanding. So you want someone to just look at your data and then at a glance they've seen what you've taken all the time and the steps to analyze. So includes charts, graphs, maps, many other visual elements. So importance of data visualization, like we said, it simplifies complex data analysis steps. So all of those elaborate steps that you've taken. You can simplify it in a compelling visualization, and your stakeholders are able to see it at a glance. So it helps in pattern recognition. So the same way that in your data analysis, you recognize that there's a trend, there's a pattern between out of school children and crime rates. You can show this in a very compelling visual, and anyone who sees it immediately sees that pattern. So it is in decision making. So your stakeholders, whoever is in charge of taking the decision, once they see it and it's compelling enough to them, they are going to just be able to fall in line with the decision you want them to take. So this slide just kind of gives a guideline because it's quite a challenge for a lot of people to know the exact type of visualization to use because there are a lot of issues with data visualization. If you use the wrong visualizations, it could be misleading, it could be entirely wrong. So it takes a lot of kind of expertise and experience to be able to choose the right visualization. So this charts essentially just helps you to try and identify the right visualization to use. Say, for instance, you're dealing with a relationship between two variables. You could deal with scatter plots. You could use a bubble plot for three variables. If it's a distribution, let's say the age distribution, you could be talking about a histogram or column charts. Scatter plots, if you have two variables, that's have a relationship. So if you are comparing two items over time, you could use a time series plots. If there are just multiple items you're comparing, not really over a specific time, you could just use your tables, you could use bar charts and stuff like that. If it's compositions, you could just use pie charts. Maybe you're looking at income across different age groups, use a pie chart. But I always like to point out that pie chart is a very misleading chart. I would never advise you to use a pie chart if you're talking about more than three categories because the human eye is not really able to read all those angles. So if you have just two categories, male and female, and maybe I was looking at income between male and female, by all means, you can use a pie chart. But when you have 5, 6 categories, pie chart is never the answer. So there are a lot of different charts. You can look at this at a later time, a lot of different charts that you can use. So in terms of tools that you can use for data visualization, see in their spreadsheets, your Excel has a lot of visualizations built in them that you can use to visualize your data. Microsoft Power BI is another one, a very, very powerful tool for data visualization, for building dashboards, building reports. It's enterprise grade. It's widely used in enterprise. So if you're looking for a first landing into data visualization, I'll strongly advise that you pick up Power BI and learn how to build visualizations in Power BI. And there's also Tableau. Tableau is similar to Power BI. For people that will want to code, there are Python libraries that can help you to build visualizations like Matplotlib, Seaborn, one of them. Same with R. ggplot2 will help you build visualizations in R as well. So let's just talk a bit about the best practices in data visualization. This is not encompassing by any means. A whole lot of textbooks have been written about best practices in data visualization. So this is very high level. You could do further reading on best practices and also comes with experience actually. But just some of them, always choose the right charts. This is actually the most important because it starts with choosing the right charts for your data. The wrong charts skews everything down the line. So you label your axis and data points because don't fall into the trap of that person looking at it to understand. So always build your visualization for the layman. Let me just use that one, layman. Don't feel that everyone has the same amount of domain knowledge that you have. So label your axis, label your data points. Use color and size effectively. When you're using color, try to be inclusive, try to use color that are friendly to the eye. Always know that there are colorblind people out there, so don't use colors that are a bit contrasting. Use size effectively as well. So just put all of these things into consideration when you're building your visualizations. Keep the charts or the visualization simple and uncluttered. Always use the simplest chart. A lot of complex charts out there. You see tree maps, you see some kind of flow charts. So you just use the simplest charts. It's always make the data easier to visualize. Keep the visuals interactive wherever possible. So you've gone to do a chart about income or whatever variable you are visualizing, wherever possible, allow your users to be able to filter this chart. So you showed me a chart about income. What if I want to see this income for last year? What if I want to see this income for just mail? What if I want to see this income for just keep it interactive wherever possible. It helps your users or whoever is reading your report to be able to answer questions they have that you did not have. So incorporate storytelling into your visualization. So your visualization needs to tell a story. You need to be able to, they need to be related. So if you have five different visuals on your dashboard, these five visuals you need to come together to tell a story, a compelling story at that. It just helps you drive that decision you want your stakeholders to take. So again, stop me if you have questions, but we can move on to common rules in the data ecosystem. Yeah, coming to the end of this, we're almost out of time. There are a lot of different rules in the data ecosystem, the professional landscape. So coming into data, a lot of people always have a challenge with which particular role do I want to do. There are a whole lot of different rules out there. We can start with data analyst. Data analyst especially focuses on collecting, processing, and interpreting data and visualization and visualizing the data, just assist with the decision making. So the key rules for data analysts are creating Power BI reports, creating business intelligence reports. Actually, it could be with any software, but you create your reports and you visualize data for your stakeholders. These are the key functions of a data analyst. Um, Next one is a data scientist. Data scientist just tries to analyze data to solve more complex problems. So imagine an organization that is trying to do predictive analysis, trying to predict which of their customers, a financial institution trying to predict which of their customers are going to repay a loan and which are not going to repay a loan. This is now in the purview of data science. So this is kind of the things that data analysts do. We are curious. They use programming languages and statistical analysis to try and build predictive and machine learning models. Also moving on. Talk about a business analyst. So business analysts are professionals who bridge the gap between what the business needs and what the data needs. So the data solution and the business needs. In between those two are the business analysts. Because typically in organizations, the business users don't really have an idea of what the data is, and the data analysts or the data professionals, the data developers don't really have a core understanding of what the business needs. So the business analyst sits in between these two groups of people and tries to understand the business processes and then propose a data solution, develop a requirements documents, and then ensure that this is done. So essentially, they just interpret what the business needs for the data analyst, data scientists, and then ensure that data analysts and data scientists understand it and are able to now build exactly what the business needs. So that's the role of a business analyst. And also data engineers. Data engineers are specialists who design and maintain data architecture, ensuring that data pipelines are efficient and reliable. So if you recall, we talked about a data warehouse from different database that you have in an organization, how the data comes into the data warehouse. This is the role of the data engineers. They write all those ETL and ELT pipelines to bring the data together into data warehouse where the data analyst, the business analyst, data scientists can then use this data. So their key roles are data integration, building these pipelines like we've talked about, and database management generally. There are also other that rules like the data architect. Data architect essentially just tries to understand the goal of the data ecosystem and then tries to make sure that the data collection and data analysis and everything is tailored to that goal. So there's also the data governance specialists. These are just the basically just make sure that data governance techniques are always achieved in terms of who has access to data, where you have access to data, and all of those things. How the data is collected, how the data is used. So these are what the data governance guys do. So this slide just kind of shows kind of a view of these different rules in the data world. At this point, I just want to mention that in terms of I get asked a lot of questions about coming in new into the data world. Where do you start? So essentially, you can start from anywhere you want. It doesn't really matter where you start from. But I always encourage that you be open to learning the different roles. You started as a data analyst, always be open to be a data engineer, always be open to be a data scientist, always be open to be a machine learning engineer, a data governance analyst, all of those things because essentially they come together. I tell people that uh, there's this stuff coming to the data world, the concept of a full stack data professional. So for software developers, you hear a lot of full stack software developer. The same concept is going to eventually come to the data world because organizations are not always going to be able to hire a separate data analyst and a separate data scientist and a separate data engineer. So you stand better chance if you are able to a large extent be these three things. At least maybe you're a data analyst at the core, but you can do some data engineering, you can do some data science. Data scientist at the core, you can do some data engineering. And so essentially you are a full stack. So it doesn't really matter where you start from, but always be open to move within these rules and learn new skills within these rules. So I'll leave you with kind of this buzzword or buzz phrase, data is the new oil. So the professional landscape for data analytics now is, or data ecosystem in general, is quite lucrative. A lot of new roles are opening up in different organizations. Organizations are realizing the huge benefits they can reap from analyzing their data. So it's quite a very lucrative landscape now, and it'll be good to just key into it in whichever capacity that you have or that you can, and progress as you go. So I think I'm way over my time, and I'll just like to end it here. I'll take questions. So please feel free to ask questions. Thank you.
Thank you, Chukwubuikem. That's quite insightful. I think we have one question now from Michael, and he's asking what PRDs are. PRDs, rather.
So I didn't get your question. What did you say?
Michael is asking what BRDs. What is BRDs?
Okay. BRDs are essentially business requirement documents. So before you go ahead to, as a data engineer, data analyst I am, if the business comes and says we want this, we want this, we want this, I'm not going to go and build this solution off a word of mouth. And I need this stuff to be specified in a technical document. You need to specify what you want. So that's that business requirement document. So that document is more like a working document for me to go ahead and develop what I want to develop. So like I was mentioning earlier, is the business analyst who sits down with the business users to develop this technical document about what they need. So what I'm developing, the solution I'm developing now, is now off that stuff, that document, that BRD that they've developed. So that's what the BRD is essentially.
All right, thank you, Michael. Did you get that? Do you have any other questions before calling it a day?